Hey guys, Nate Story here with Bright Agrotech, and today we are going to talk about hydroponic nutrient solutions. 1-part, 2-part, 3-part, multi-part, all these different kinds of solutions. You've got liquid and you've got dry. We're going to talk mostly about dry fertilizers because they're the most economical for commercial growers. So there are 16 plant nutrients, technically, right? We've got carbon, oxygen, hydrogen. These are the things that are supplied by CO2, by oxygen, and by water, right? And they're oftentimes left off the list. You don't have to supply these. Of course, you have to supply water, you have to supply CO2. These things are important, right? But the biggie that we tend to focus on when we're talking about fertilizer are the 13 mineral nutrients. So there's primary, secondary, and then micronutrients. The primary nutrients are the nutrients that basically are used in the highest quantities and the most required for plant growth and development. These are the most common building blocks for the plant. The secondary macronutrients are needed almost as badly as primary ones, and there have been many arguments for including many of the secondary macronutrients as primary nutrients. However, for the time being, they are classified as secondary macronutrients, and they're still very, very, very important, but not quite as important as the primary plant nutrients. The micronutrients are all of the mineral nutrients required in much, much smaller quantities by the plants for growth and reproduction, okay? And all of these nutrients, both the primary, the secondary macronutrients, and the micronutrients are all supplied by hydroponic nutrient solutions if you're doing hydroponic production. So the primary nutrients are nitrogen, phosphorus, and potassium, right? NPK. And these are on the label of every major fertilizer because they're the most important. It's really important that you understand how much of each one is in a particular fertilizer. So nitrogen, incredibly important for plant growth and reproduction. It is incorporated into all sorts of molecules that are involved in photosynthesis. So chloroplast, photosynthesis, nitrogen is very important. It's very important in proteins, right? These are not just photosynthesis specific proteins, but proteins that operate all through the cell. Phosphorus, important part of the cell membrane, important part of all of these different biological molecules. And then, of course, potassium, plant signaling, root growth and development, reproductive growth and development. These are all really, really critical nutrients to plant production and to growers who are interested in maximizing their plant production. Secondary macronutrients, calcium, magnesium, and sulfur are very important in, calcium is super important in bonding cell walls. It's a structural element. It doesn't, calcium's a really weird one. And actually there's been a lot of people that have argued that calcium should be a primary plant nutrient, and it typically is supplied in very large quantities in hydroponic solutions as a result. Magnesium, an important part of the photosynthetic kind of complex. Sulfur, incredibly important in peptide bonds and DNA and all of these different molecular biological compounds and biological molecules that the plant needs to grow and to reproduce. Essentially, the reason that the primary and the secondary macronutrients are so important is because they're the most common nutrients. They're used throughout the plant for a variety of different activities. The micronutrients are still absolutely critical. Without any one of them, the plant will die or can only survive for a certain number of generations for things that are only supplied in very small quantities. Some of them are required in such small quantities that the parent plant producing a seed, in that seed is enough of that micronutrient for the entire life of that daughter plant. However, the seed that plant produces, if it doesn't have enough, the generation after that will fail. So some of these are required in very small quantities, but they're still required. And that is kind of the key thing with the micronutrients. Just because they're required at fairly low levels does not mean they're critical. So the way that we measure hydroponic fertilizers is with a measurement called EC. It's short for electrical conductivity. And basically what we're doing is we're sticking a probe in the water and we're passing a current between these two probes, and the way that current is transmitted is basically the strength of that current tells us how many soluble salts are in that water. Right, so how many ions we have floating around in here, and how easy is that electrical current passed from one probe to another. So EC is measured a variety of different ways. If you're measuring electrical conductivity property, it's mostly milliohms or microsiemens per centimeter. Those are the two primary measurements. ppm is sometimes used, but that's more for total dissolved solids, which is a slightly different measurement. We typically shoot with most hydroponic solutions for something, we're usually using millisiemens per centimeter, and we're usually shooting for somewhere between 1.2 for plants that really don't like a whole lot of salt or uptake a ton of water, all the way up into the low 3s for some crops that are more salt tolerant that we want to pump full of nutrients. So there's a broad range there that is specifically crop appropriate. And if you have questions about what your EC value should be for each individual crop, check out the crop production guide that we publish. It's got all of that information there. So EC is a really, really simplified measurement of a very complicated thing. Now the great thing is with modern chemistry, all of our solutions are formulated. That means we know exactly how much of each element is in each thing. And we can formulate these nutrient solutions specifically for individual crops. What that means is if we put it all in at the right ratio and the plants are taking everything out at the exact same ratios, then by measuring the electrical conductivity, we can tell the salt content of the water or how much nutrition is actually there. And if it's all being taken out at the exact same rates, we don't usually end up too far off balance. What this means is with a formulated solution and with this simple EC measurement, we can measure when we need to add more nutrients to the water and when we have too much nutrients in the water. So EC measures the amount of these soluble salts that are in the water, right? The amount of fertilizer that we have in the water. Now, the availability of that is still somewhat variable depending on a measurement called pH. pH measures the acidity of the water, so how acid or how basic the nutrient solution is. And what the interesting thing about it is it doesn't matter if we've got the right amount of plant nutrients in the water if our EC is so far off because different nutrients are soluble at different pH values. So pH influences the solubility of each individual nutrient. So there are lots of graphs online. If you just Google, what is it? Nutrient solubility chart, something like that, you're going to get a host of images that show these bands across multiple pH values that tells you where the ideal, the most soluble pH value is for each individual mineral on that list. Now it's important that we're managing both EC and both pH because EC puts the nutrients in the water and pH makes the nutrients available to the plants. And that's the critical thing. Those are the two most important things when it comes to managing your nutrient solution and making all of those plant nutrients available for your plants. So optimal pH is typically somewhere between the low 5s and the low 6s for most crops. Some crops will prefer it a little bit higher. Some crops will prefer it closer to 7. Some crops will prefer it in the high 4s. But generally, if you're within that range, you're within the range that plant nutrient uptake is optimized for most nutrients. So there is kind of an optimal pH range in there, and depending on the mix of crops that you have, you should be optimizing your pH to make your nutrients as available as possible to the most number of crops possible. So when we're talking about pH, the understanding is that you have to adjust pH up or pH down to get your pH within the range where you have maximum solubility of those plant nutrients. To do that, you're going to either use something called pH down or pH up. And people in the industry will call it pH down, pH up, but typically what it's describing is pH down is an acid. It could be any number of acids, and pH up is a base. It could be any number of bases, but is most commonly potassium hydroxide. And so you've got this combination of acids and bases. You should only probably be using one in your system. If you're using both an acid and a base, you're probably doing it wrong, and you're probably adding a base which raises your pH and then an acid that lowers it, and you're just fighting yourself. So pick one and run with it depending on whether your system trends up or trends down most commonly. So there are two basic types of fertilizer out there. You've got dry and you've got liquid. Now dry is usually used in commercial settings because it's very inexpensive to ship. The big cost here is not actually the chemicals, it is the shipping. Right? It's the shipping. So if you dilute down dry fertilizer to make liquid fertilizer, say you take 1 pound and turn it into 100 pounds, it of course costs a lot more to ship that around the country. That's why most commercial growers use dry mix. You can also tailor dry mix a little bit better to your needs if you're a big commercial grower with very crop-specific needs. So it usually comes in 1, 2, 3, or multi-part mixes. We tend to use a 3-part mix around here. You've got part A, part B, and part C. Part A is your basic general nutrient mix. It has your NPK, it has almost all of your micronutrients and your secondary macronutrients. Your part B is calcium nitrate. It is mostly nitrogen and calcium. It is not very soluble, and so it's kept separately. You dissolve your part A, and then you dissolve your part B, and you dose them equally into your system. Your part C is almost always magnesium sulfate, or Epsom salt. This is magnesium and sulfur, and is the primary way that we supplement magnesium in the system. So these 3 things mixed together, mixed in at the correct rates, and for the solution that we use, it's half a pound, and 1/3 of a pound. For part A, part B, and part C to get the right kind of mix for almost all of our crops. If you mix them at the right rate and you add them at the right rate to your system, they will be in the correct ratio, nutrient-wise, for your plants in your system. The other kind is liquid fertilizer. This is more of a home and hobby because it's simple. Usually it's 1 part. So you're just adding this 1-part solution. It's very simple to measure, very simple to manage, much less complicated than dry fertilizers. However, it is a lot more expensive to ship, but most people don't care because they're using it on a much smaller scale. So most liquid fertilizers are 1 part, but there are 2-part, 3-part, multi-part liquid solutions. Almost all dry solutions are either 2-part, 3-part, or multi-part solutions. Now, whether or not people want to deal with like a 10-part mixing process, you know, that's kind of a good question. Unless you're a very big producer or a grower, you're probably not messing around and mixing all of these different dry chemicals together to get your solution. You're probably buying a 2-part or a 3-part from a major supplier, and you're mixing them on site, specific to your crops and specific to your needs. So the reason that a lot of these nutrient solutions are separated out is because their solubilities are different. So for the part A, for instance, for a 3-part solution, the part A is very soluble. These are highly salts that dissociate very quickly in water. They are very soluble. Calcium nitrate, on the other hand, is not. It is hard to get calcium nitrate dissolved. In fact, we typically use hot water, and we have to be really careful at the rate that we're mixing it to water to make sure we can get it all dissolved. Because if it isn't, then your dosing ratios are going to be a little bit off. Your part 3 Epsom salt, again, is very soluble. And so what we're dealing with here is 2 parts that are highly soluble and 1 part that isn't. And that's why they're kept separate. Because if you tried to mix them all together, you'd get certain elements precipitating out while other elements stayed in solution. And what you would end up with is plant deficiencies in those nutrients that happen to be precipitated out. So to be clear, when we talk about 1-part, 2-part, and 3-part solution, we're not talking about primary, secondary, and micronutrients. What we're talking about here is the best chemistry for getting all of this stuff mixed together. So part A, for instance, it actually has almost all of the nutrients there. Right? It has almost all of the plant nutrients included in that solution. However, we need a lot more nitrogen than we can get in that part A. So that's why we add calcium nitrate. Also, we don't have as much calcium in part A, right? So use calcium nitrate because it's very inexpensive to manufacture, and it's a great molecule for supplying both nitrate and calcium to our plants. So that's kept a little bit separate because of solubility issues. And then magnesium sulfate is by far the cheapest and best way to supply magnesium to the solution. So what the chemists are doing is they're going through and they're figuring out the optimal way to group all of these nutrients together so that they're supplied in ratio to the plant's needs, and they're supplied in a way that the user can mix them very easily. So we're mixing a 3-part solution. The easiest way to figure out how to mix that is to just take the manufacturer's word for it. Over time, as you do it more and more, you might tweak it, you might change it a little bit for your specific setup, but by and large, when you're starting off, you can just go with the instructions from the manufacturer. So for us, we're growing strawberries right now, and we're using a strawberry mix from ZipGrow. So if we go to the ZipGrow website, it says to mix 0.375 pounds of part A, 0.37 pounds of part B, and 0.25 pounds of part C. So what we do is we go out and we measure out 0.375 pounds of our part A solution. We set that off to the side. We measure 0.35 pounds of our calcium nitrate, or our part B. We set that off to the side, and we measure out 0.25 pounds of magnesium sulfate, or our part C, and we set that off to the side. Now you can mix these into 3 separate buckets full of water. The important thing is to make sure that there's the exact same amount of water in each bucket. However, what I prefer to do is mix the part C and the part A together because they're both highly soluble. That means I can mix both of these in and makes a nice salty concentrate, but it doesn't typically cause anything to precipitate out when I mix this amount of fertilizer into a 5-gallon bucket of hot water. The calcium nitrate is always off on its own, so I'll mix that into this separate bucket with nice warm water, and what I end up with is 2 buckets that run really, really nicely off of our IntelliDose system and pump the exact correct ratio of nutrients into our main solution. So if you are using an auto doser, that's all well and good. That all makes sense. If you're hand dosing, it's a little bit different. What I recommend people do if they're hand dosing is they still mix it the exact same way, but they add it to their system and they check their system to make sure that they're not adding too little or too much, at least when you begin. When you get really, really good at hand dosing, you know how much your crops consume on a daily basis. It is really, really consistent, and it gets much, much easier to just walk in, mix the right amount of nutrients, dump it in your system, and walk away and know that you've mixed it correctly. But right off the bat, on the front end, if you are hand mixing, you're going to mix these 3 separate tanks, or 2 separate tanks, and then you're going to add concentrate from those tanks in ratio. So if you add 1 cup of part A, you're going to add 1 cup of part B, mix it, measure it, and then repeat. So that's the goal, is to make sure that you, if you are hand dosing, that you're not messing up the ratios there and that you're mixing it correctly. So if you're hand dosing, you have to be monitoring. If you're auto dosing, the thing is monitoring for you. You should be calibrating it, you should be double checking it every now and then. But if you're hand dosing, you should definitely be measuring your EC and your pH quite regularly. And especially throughout the dosing process, as well as preceding the dosing process. So you want to go in, you want to measure your water, you want to say, okay, my solution is at too low in EC and too high a pH. So dose the EC first. So first you add EC, you get your EC to where you want it, then you remeasure, and then you dose your pH to where you want it. So first EC, then pH. Measure it beginning, throughout, and at the end. So when it comes to EC, there are lots of measurement devices out there. There's very traditional kind of EC, handheld analog EC measuring devices. I've used those quite often. There are handheld testers made by folks like Hanna and Blue Labs. There are tons of different devices out there. We use the NutriTester from AutoGrow, as well as our auto dosing system. It's measuring that as well. But if you're hand measuring, there's tons of handheld EC meters out there. If you're testing pH, you can use anything from colorimetric tests, where you're dripping little drops of chemical in there and it's coloring the solution depending on the pH. You can use tabs, basically little strips of paper that you can dip in the water, and you can also use handheld testers. So there's a variety of options depending on how specific you want to get and depending on how much money you're willing to spend on that testing device. So to wrap this up, let's review really quickly what we've gone through. So we went through the 13 mineral plant nutrients in detail, explained how all of these are available in nutrient solutions, whether they're wet or whether they're dry. We talked about measuring electrical conductivity and what that means and how we use that EC measurement to make sure we've got the right amount of mineral nutrients in our solution. We also talked about pH and how basically your pH value impacts whether or not the nutrients we're putting in the solution are available to the plants and to what degree they are available to the plants. We talked about liquid versus dry, how liquid is great, it's simple, it's easy, but it's much more expensive to ship, which makes it much more expensive for you to use, versus dry, which is much more difficult to mix, handle, and manage, but is much cheaper to ship. And why those two things have caused liquid to be the most commonly used type of fertilizer in home and hobby applications, while dry is the most commonly used fertilizer in commercial applications. We talked about mixing 3-part solution last And we basically explained how that works, how to do it, and why it's important to mix those things separately and understand how the solubility of those different nutrient parts impacts the way that you mix them and the way that you dose your system with them. So on all of these different subjects that I've just briefly touched on, we have written resources and blogs. You can find those in the link below. We have a ton of YouTube videos that go into a lot more depth on each of these issues as well. Again, linked below. And if you haven't joined Upstart University yet, I would highly encourage you to do so. We do an entire course on fertilizers, mixing fertilizers, starting your farm, doing all of this incredible stuff that's necessary to understand to get a farm going. And we cover all of that on Upstart University. If you have not joined, please do join today. Thanks so much for watching. I hope this was helpful. And as usual, if you found this useful, if you found this to be something that you enjoyed, please subscribe.